Okay, here we go. Got a question about focal lengths of converging lenses. Okay, we've got the apparatus. Hopefully this is familiar. And yeah, usual story. Have a look at the question, and when you're ready to watch an explanation of the answer, okay, please press play. It's very much one of the standard experiments that you get in your alternative to practical paper. This is kind of quite a common one. We've got a lamp illuminating the lens, and then we've got a screen. So we're looking at the formation of images here. Okay, we've got the procedure, and again, whether you need to read the procedure or not, I don't know. I think sometimes with paper 6, a lot of text, you don't need to know all the information. It's good to know what's going on. Okay, so you've got the lens being placed at a particular distance. We're going to switch on the lamp, we're going to measure, and then we're going to look at the image, and we're going to measure the distance between the object and the screen, etc. Okay, so really, you know, it's a basic experiment, okay, and this repeats a lot. The things that we have to do here, firstly, is to measure some distances. So we've got the position of the screen where we have a sharp image, okay, we want to know the value of p to the nearest 0.1 centimeters. You can see here we're at 61, so we're going to 60 point something. What's that point something? 60.1, 60.2, 60.3. There we go, 60.3 centimeters. Okay, now this question I did not like because it involves lots of calculations. So firstly, we're going to calculate the distance v, and they give you an equation, v equal p take away 30, 30.3. Okay, we're then asked to record things in the table. So I actually thought there was a lot of recording to do here. Okay. We're going to be jumping back and forth between this table and other sections of the paper just to make sure we've got our data in. So we then do the experiment again. Okay, we measure a new value of p. Okay, in this case it's going to be 71.1234567 There we go. And we're going to calculate again using the same equation. Okay. And we're going to record it in here. So just make sure every time you're going back, never leave a table blank. If you've got a table to do, make sure you fill it in. Okay, so we've got our data for V. Okay, we then later have to calculate some other things, but we'll come back to that in a second. Okay, now one reason I'm kind of happy to have this question is because we talk about difficulties. Okay, one big difficulty in following the procedure in this experiment is basically just making sure that you've got a clear and focused image. If you've ever used an optics bench, it's quite hard to make sure that you're getting a focused image. Or it's quite hard to know that you've got a focused image because you know, we're relying on our eyes to make sure we decide between a blurred or a sharp image. It's not like you're looking for a number. You're looking kind of qualitatively at the quality of the image. So I would say it's quite hard for people to make sure that you've got the image to be clear or focused. Okay, now how we can overcome that, okay, this is a standard answer, is by moving the screen slowly back and forth. So what you do is you imagine you're kind of just adjusting it every now and again, just making sure you're slowly moving it, and then maybe moving it too far in one direction, so back again and back again, zeroing in, homing in on that sort of clear image. So the standard suggestion here is to make sure that you move it back and forth slowly. Okay, as you saw on the table, we've got to do some calculations, u times v. Okay, I'm not going to go back to my table because it's just jumping around too much. I put these in the table. We've also been asked to state some units. That's quite a nice one. While u and v are both distances, they're measured in centimeters. So we've got a unit of centimeters squared. Okay, just trust the units here. If you've got time times time, that makes second squared. If you've got meters times seconds, that's meter seconds. Okay, just take the units, multiply them together, and then move on. We're then calculating u plus v, recording them in a table. I didn't even write them down here. I think I just got a bit annoyed. And then finally had to calculate my values of u times v over u plus v. Interesting there. We've got very similar answers there. This should be the same because what you're calculating here is the focal length. I think this is really interesting. In GCSE physics, you don't really learn about the theory of lenses. Okay. However, there is a relationship that 1 over f equals 1 over u plus 1 over v, which basically means this. Okay, and so these numbers are basically the same. Yep, and I've entered them in my table. I presented them to 1 decimal place or 3 significant figures because the other numbers were given to 3 significant figures. So I had 909 over 60.3, 15.1, 3SF. Same for this one, 3SF, even though this looks like a significant figure, it's not. 71.8 to give 15.2. So generally, 3 significant figures is required. Okay. We're then told that the student does it again using a different value of u, and we find v. We're asked to describe the relationship between u and v. Well, hopefully, and I'll tell you what, I'll scroll back just so we can see it. Hopefully we can see that we've got a relationship there that is, we've got 30 becoming 30.3 and 50 becoming 20.8. So v, u up, v down. Okay. Now this is one point where I think students get a little bit worried as what they need to write down. All you are being asked to do is to describe relationships. Okay, and I've seen this a few times. I'll hopefully link this to a few students because you're just being asked to state the basic relationship, no proportionality or anything like that. As u goes up, v goes down. Yeah, and that's what you'll see in your table as well, using these 3 sets of values. We do not need to say they're inversely proportional. We don't need to say they're directly proportional. We just need to say one goes up, the other one goes down. Okay. Last one. Oh, this is where, yes, I'm really glad I'm filming this because I realized when I wrote this, I wrote something incorrect. Okay. Two students do another experiment, I should say, to determine the focal length. We have a focal length of 10.6. And they determine a value for f and repeat the experiment 3 more times. So we've got these lovely bit of data. Now, this is where, as you will see, I did not read the question. I'm a bad person. Okay, I wish I had reread the question because what you're going to see is my answer is wrong. Tell you what, I'll write it down and you can see. Okay, it says to you, use the data in table 5.2 to explain why the results for student B are more accurate. Now, I'll be honest with you, I misread the question. I thought it said more precise. I don't know why. I was doing it quickly. Okay, I was doing a physics experiment at the same time and I misread it. This would be correct if it said precise. However, it's all about accuracy. Okay, precision is about the range in the data. So you can see here that student B's data, okay, is quite nicely packed together. You got 10.6, 10.5, 10.4, all close together. Now, if we were to calculate the average of that data, I would get somewhere around the 10.5 mark. Okay, now notice that is very close to the 10.6. Student A, however, has a much wider spread. Okay, if we were to calculate the average of this trial 3 would cause a much higher average and therefore a less accurate result. Okay, so my answer here is not correct. Okay, all right, I would not get a mark for that because I misread it. Student B's data is more precise because there's a smaller range, but it's also more accurate because the average would be closer to the actual value 10.6. We know f is 10.6. All right, and this data is 10.5. This data would have a higher average, and therefore it is closer. So my apologies, I've written the wrong thing there. I want to make you clear that this is not correct. Precision, small range, accuracy is closer to the result we want. Okay, hopefully I've not got the next bit wrong. That would be terrible, right? The students use an identical ruler to measure the height of the image on the screen. Okay, they each take a single measurement and they record the results in millimeters. Okay. We're told student A 21.2 millimeters, student B 21. It says the result from A is not correct. Why? Well, this time I've got it correct. The problem here is this level of precision, right? When you use a ruler, you can measure to the smallest millimeter, to the smallest division, which is a millimeter. You notice here the smallest division is 1 millimeter. We cannot measure 0.1 millimeters. That's far too small. Okay. You could do that using, for example, a caliper or a micrometer, which are both much more precise bits of kit. However, they are not going to be, but you can't do that using a ruler. All right, last one. Oh, yeah, I remember this. There's a blank page for some reason. There we go. Okay, right. And then last one, we've got an illuminated object. Okay, so this is the object. What you've got here is the light shining through this thing. Okay, and here's the object there. And it tells you something quite nice. We've got the object produced on the screen is inverted and enlarged. That is image C. And then with a different lens system, the image is upright and diminished. So we've just been asked to draw them. Okay, quite like this question. All right, inverted and enlarged, that's image C. Upright and diminished, we're looking for something like this. Okay, in image C, you're going to have an image which is inverted, so flipped. Okay, it's going to be vertically inverted, so the top is going to become the bottom and the bottom is going to become the top. And in the case of the image D, it's upright and diminished. It means it's getting smaller and it's going to be upright. Okay, 2 nice marks there. Just follow the instructions. Okay, it's for a total of 13. This is quite a lot of marks, right? In the physics section of your paper, it's 20 marks. So 13 of them are coming from this kind of question. Okay, you see there a couple of bits I tripped up on when I first did it. So I hope you didn't trip on them too. If you've got any questions, please let me know.